Hello and welcome to Functions Quiz Review. This is where you are going to be grading yourself on this review and giving yourself a score, pretending if this was the actual test, what would you get? So we're going to walk through all the problems here. Starting, make sure that you note the directions to use interval notation. So for problem number 1, first question, is it a function? I'm looking to see, does each x value have only one y value? And I can use the vertical line test to see, is there a place where this x value hits two different y values? That's happening here. This x has two different y's, so this is not a function. That's one point. The domain, we're looking at all the possible x values. And it looks like this graph goes 1, 2, 3, 4, from 4 all the way down to negative infinity. So we always do an open, negative infinity, up to positive 4. And since it looks like it is included, we're going to include that in the domain. The range, we're looking for all the numbers. It looks like it goes all the way up, and it goes all the way down. These arrows will keep it going all the way up and all the way down. So this is negative infinity to positive infinity, or you could also write all reals. Number 2, is this one a function? Does every single x have only one y? Yes, it does. So this one, yes, is a function. The domain here, this goes from negative 2 to positive 1. All of these x's are included here, but the negative 2 is not included. So we'll go negative 2 open to positive 1 closed. The range, we're looking this way. And it looks like it's 1 to negative 3 up to 1, 2, 3, positive 3. All the numbers from negative 3 to positive 3. Negative 3 is included, but it looks like positive 3 is open, so that is not included. Okay, problem number 3. Is this one a function? Every single x has only one y. Sometimes these arrows make it look like it's going vertical, but it's actually, because this is a parabola, it's getting wider and wider and wider and wider. So this one is a function, even though sometimes the drawing misleads us a little bit. Domain, is it going left? Is it going right? It's going all the way left and all the way right, so this is all reals, negative infinity to positive infinity. And the range goes from 1 up. So we're going to go closed from 1 up to positive infinity. Okay, so 3 points, 3 points, 3 points. So far we're 9 points in. Grade yourself. Mark it correct. If it's perfect, if you even messed up an open or closed, any little part of it, mark that wrong, because that's how I'll grade it tomorrow. So right now, 3 points, 3 points, 3 points. Okay, here's the next ones. Is this a function? It's going straight up and down, so this x value of 4 has all these y values and all those y values. There's an infinite number of y values, so this one is not a function. The domain, the only possible x value that works here is 4, so we could do this and just say 4 is the only x value. The y value, though, it goes all the way down and all the way up, so this one is negative infinity to positive infinity. Is this one a function? Yes. No x ever has more than one y. The domain is going to be negative infinity to positive infinity. And the range is just this height, 1, 2, 3, 1, 2, 3, 4, just negative 4. Is this one a function? We look this way. Does any x value have more than one y value? No. You notice that this y value here has two different x values, but that's all right if one output has two different inputs. But does every input have only one output? Yes. Domain is going to be this number, 1, 2, 3, 4, 5, 6, negative 6, negative 2, positive 1, and 1, 2, 3, 4. Those are the 4 numbers that x can be. Y can be negative 2, 2, and 3, 4, 5. Again, grade your own. We are up to 18 points at this point. 3, 3, 3. The next question is a situation. Mr. Dingman has changed his classroom policies. From now on, every student will receive two grades, a correctness grade and an effort grade. So think about the function machine here. Here's Mr. Dingman. We are putting inputs in. We could have inputs going in. Every single student could be the input. So we have lots of inputs. But whatever student goes in, we're getting out two different outputs. A correctness grade and an effort grade. So if the input has two different outputs, is it a function? No, not a function. 1 point for that. Domain, every student, all of the students. So you can just say every student. Those are the possible inputs. Range, we have two things that are coming out each time. A correctness grade and an effort grade. And since we've got two different outputs for one input, it is not a function. 3 points. So right now we're at 24 points. Score up what you got on the front page. Make it a score out of 24. Okay, page 2. Is this a function? Remember, we're looking to see, does every input have only one output? Is 1 has 1, 3 has 1, 6 has 1, 4 has 1, 5 has 1? Yes. Explain each x has only one y. This is 2 points, one for the answer, one for the explanation. Is this one a function? The 1 has a 1, the 3 has -5, and the 3 has 2. So you notice that the x value, the input of 3, has two different outputs. No. The x value of 3 has two different y values. If your explanation was not good, mark off a point, because I will tomorrow. 2 points. Okay, here I give you a graph and I ask you to provide the info. Where is it increasing? As we move, we're always talking about moving left to right. Where is it increasing? The whole time it's increasing. So this is from negative infinity to positive infinity, it is increasing. Where is it decreasing? Never. Where is the x-intercept? Looks like it's right about here. -1. That is a coordinate, -1, 0. Where is the y-intercept? +1. So 0, +1. Does it have a max or a min? No. Because it's not coming up and curving, it's not coming down and curving and going back up. This one has neither. But as x approaches negative infinity, as it's going this way, what is it getting close to? It's not getting close to negative infinity. It's not getting close to positive infinity. It is getting close to this number, -3. It is getting closer and closer and closer to x equals -3. Actually, this is y equals -3, sorry. This is the line y equals -3, and it's getting closer and closer and closer to it. So as x approaches negative infinity, we are approaching -3. This is called an asymptote. If I ask you for an asymptote, yes, it has an asymptote at y equals -3. As x approaches positive infinity, what's happening now? Oh, it's going up. It's getting closer and closer and closer to positive infinity. So this is called the left end behavior. It's approaching -3. The right end behavior is it's approaching infinity. This is an exponential function. Okay? Next one. I give you information. You draw the graph. First, look for the important points. X-intercepts. -3, 0. -1, 0. Y-intercept is 0, -2. There's a max at -2, 1. Okay, from here, and I see it's increasing from negative infinity up to -2, and then decreasing from -2 to infinity. So my graph is coming up like this, and then decreasing. That's what I'm looking for. As x is approaching negative infinity, it's going to negative infinity and negative infinity, both ways. This time I give you the graph, and I'm asking you for the information. Where is it increasing? From negative infinity up until here, what is this? 1, 2, 3. This is negative 3. So from negative infinity up to negative 3, it is increasing. And then it starts to decrease from negative 3 to 0. But then it turns to increase again from 0 to positive infinity. So we've got another interval here, 0 to positive infinity. We are increasing. So it's increasing to here and increasing to here, decreasing in between. Does it have any x-intercepts? Yes, it does. 1, 2, 3. This looks like 1, 2, 3, 4, 5, 6. This is negative 6, 0. It looks like it's about negative 1, 0. And positive 2, 0. Does it have any y-intercepts? Yes, negative 2, 0, negative 2. Does it have a max? Yes, this is the max. 1, 2, 3, 1, 2, 3, 4. Negative 3, 4. Does it have a min? 0, negative 2. It's also the min. As it approaches negative infinity, we are getting closer and closer to negative infinity. We're going down. Oh, that's a terrible infinity. Not good enough there. And as it approaches positive infinity, we're going up. Okay, so that is page 2. Grading wise, I'm looking here to see, this will be like probably a 3-point problem to see if you put things on here correctly. This is 1, 2, 3, 4, 5, 6, 7, 8. There's 8 points here. 3, 11, there's 11, and this one is also looks like this one is 8. So we're at 19 and 2 and 2, which is 23 points on this page. So give yourself a score out of 23 on the page 2. Page 3. Draw a sketch to represent the situation. A man deposits $100 in the bank and never deposits more money. It earns interest over a period of time. So it's getting more and then more and then more and then more. Every time that we have, like his money earns interest, and then his interest earns interest, and then that interest earns interest. So that is not a linear rate. In fact, that is an exponential rate. He puts $100 in the bank, so at time 0, time money, at time 0, he has $100, and then it's going exponentially bigger. Okay, that's what we're looking for. A man is shot out of a cannon. Sounds like fun. Show his height as a function of time. Here's time, here's height. When he's first shot, he's probably on the ground, and then he's shot out of the cannon, and he comes down. That's a quadratic. Anytime we're throwing things up in the air and they're coming back down, it's quadratic. Jason sets up a Nutty Bar stand in the school cafeteria, and he sells Nutty Bars for 25 cents. He makes 10 cents for each. This is important. That means it's a constant rate of change. Show his profit as a function of the number of Nutty Bars. So here's my number of Nutty Bars, and this is my profit. If I don't sell any, I'm at 0, but then I make 10 cents for each one. This number doesn't even really matter. It's a linear relationship. Okay. Linear, quadratic, or exponential. Remember, we look for the differences first, and we see if it's a constant rate of change. 12 minus 14, this is negative 2, negative 2, negative 4, negative 2. Uh-oh, I did this one wrong. I think this was supposed to be linear. This one was supposed to be linear, so change this problem to 8 and 6. My mistake. This one is supposed to be linear. My bad. This one, so 2 points here. This one is going up 3, then going up 9, then going up 15, then going up, looks like 21. So then, it's not linear. I do second differences. 6, 6, 6. These are the same. If the second ones are the same, it is quadratic. There's 2 points there. And then the last one If you do this, it's not the same. If you do the second differences, it's also not the same. But if you divide, 27 divided by 81 is 1/3. 9 divided by 27 is 1/3. 3 divided by 9 is 1/3. And 1 divided by 3 is 1/3. So this is the constant here, and so this is exponential. All right, that's also 2 points. So together we got 2, 4, 6. These are 2 points each also. And 2, 4, 6. So this is 12. We add 12 to the 23 makes 35. And 24, I think, on this one gives you 35 and 24, that is 59 points. So out of this, give yourself a score out of 59. I'm going to see that score when you turn it in to me. Have a great day.